Hello and welcome. Our topic for the day is dividing radical expressions, includes variables, and requires rationalizing the denominator. To understand the concept, let's do some questions. In the first question, it says simplify, and we're given two expressions to be divided. Let's write our question. It says a square root of 4a6 b5 divided by negative 3 square root of 3 a squared b squared. Now the steps that we follow is, first we simplify inside the radical sign and see whatever can be pulled out, and then if there is a radical sign in the denominator, we'll rationalize it. Let's see how we do it. The first step is to first simplify inside the radical. Here we have a inside the radical. 4 can be factored as 2 times 2. A to the power of 6 can be written as a squared times a squared times a squared. P to the power of 5 can be written as p squared times p squared times p divided by negative 3 inside the radical. 3 will be as it is, a squared and p squared. Now we'll see what all can be pulled out in the numerator. We have a times a pair of 2 come out as a single 2, then the first a square as a, then the second a square as another a, and the third a square as another a, then the first p square as p and the second p square again as p, and inside we are left with just square root of p. In the denominator we have negative 3, the a square comes out as a, the p square as p, and inside we are left with square root of 3. So we'll see what all can be simplified. A cancels with a and one p goes with another p. So we finally left with 2a cubed and a p. A cubed and 1p. Inside the radical we have p, while in the denominator we have negative 3 root of 3. Now here we have a radical sign, that is a square root 3 in the denominator. This can be eliminated when it is rationalized. Rationalized means we multiply and divide the expression with the number or the quantity that is inside the radical. So how we do it? We do it like 2a cubed p square root of p divided by negative 3 square root of 3. As we said, square root of 3 multiplied and divided by, like this. So now we'll put the terms on the numerator together. So we have 2a cubed p, inside the radical we have p times 3, while in the denominator we have negative 3, inside the radical 3 times 3. Now this can be further simplified. On the numerator this comes to negative 2a cubed p square root of 3p. On the denominator we have negative 3, sorry, the negative is gone on the numerator, so we have 3 times 3. These two 3's come out as a single one. So the final answer comes out to be negative 2a cubed p square root of 3p divided by 9. This is our final answer, can be seen in option A. Let's move to the next question. It says simplify, and we're given 2b square root of 25 b4 g squared divided by bg square root of 2b. So our rule remains the same. We first factor out the radical. Inside 25 can be written as 5 times 5 b squared times b squared and g squared. In the denominator we have negative bg square root of 2b as it is, nothing can be done. So on the numerator we can pull out from the radical two 5's as a single 5, the first b square as b, then the second b square as another b, and a g from there. So that's it. Nothing inside the radical is left, so we have negative bg square root of 2b. Let's see if we can cancel something. B goes with one b and g goes with another g. So we have the negative comes in the numerator, negative 10, 5 times 2 is 10, and we have b squared divided by square root of 2b. Now we need to rationalize. For this we multiply and divide like this. So we have negative 10b squared square root of 2b. In the denominator we have square root of 2b times 2b. This is equals to negative 10b squared square root of 2b divided by 2b, because inside we can pair these and this comes out as a single 2b. So we can simplify this. This turns to 5 and b squared divided by b is only b. So this is negative 5b square root of 2b as a final answer. This can be seen in option B. Let's try the next question. It says simplify, and we're given t square root of 16 q squared t squared divided by negative 3q squared t square root of 32 qt. This is equals to t inside the radical 16 can be factored as 2 times 2 times 2. Q squared can be written as it is and t squared as it is. In the denominator we have negative 3q squared t. 32 can be written as 2 times 5 2's and a q and a t. Now from the numerator we can pull out, let's see, t as it is, then the first pairing of 2, then the second pair also, then we have q squared as q and t squared as t. So everything is out the radical now, nothing is left inside the radical. In the denominator we have negative 3q squared t, so we have like this. Inside we're left with 2qt. Let's simplify if we can something. The 2's cancel with the 2's over here. The t goes off with the t. 1q in the numerator cancelled with one of the denominator. So here we are left with t times, I think there's nothing left in the numerator. In the denominator we have negative 3q square root of 2qt. Now this can be rationalized by multiplying and dividing with the radical portion. So in the numerator we have t times square root of 2qt, while in the denominator we have negative 3q. This is 2qt times 2qt. This is equals to t square root of 2qt divided by negative 3q times 2qt, because these two combine to come out as a single 2qt. So the t cancels with the t and we are left with negative 2qt in the radical sign divided by 6q squared. This is the final answer and can be seen in option C. I hope dividing radical expression that includes variables and requires rationalizing denominators is easy now. Thank you for watching and have a nice day.